The unknown quantity in the balanced chemical equations can be calculated by the following method. For example, the first we need the balanced chemical equation, and then we convert the mass given in the balanced chemical equation into the mole. And we find the unknown, the mole of reactant or the product with the reference of molar ratio in balanced chemical equation. And then we convert the unknown mole into the mass. For example, we're having what mass of aluminium oxide is produced when a 9.2 gram of aluminium metal react completely with oxygen gas. So the first we're going to write the balanced chemical equation. For example, the aluminium react with oxygen and produce aluminium oxide. So we're going to see that is it a balanced chemical equation? If it's not, the first we will convert it into a balanced chemical equation by adding coefficient. And then we're going to find what we have. For example, in the balanced chemical equation, we have the molar ratio of aluminium, and the aluminium oxide is 4:2. While the aluminium mass is given, this is 9.2 gram. So first, we're going to convert this mass into the mole by using molar mass. So molar mass of aluminium is 27 gram per mole. So we're going to divide 9.2 gram divided by 27 gram per mole. So this will give us 0.34 moles. So we're going to use this molar ratio. For example, aluminium with the reference of aluminium oxide. So with the help of balanced chemical equation, 4 mole of aluminium are producing 2 mole of aluminium oxide. So 0.34 moles will produce how much quantity of aluminium oxide? So we're going to find by cross multiplication method. So x is going to multiply with a 4 and 0.34 going to multiply with a 2. And this will give us this next step, the following value. Now, 4 mole is multiplying with x, and this is going to divide on another side. And that will give us the mole of aluminium oxide. And that is 0.17 moles. Now, in the question, we need the mass of aluminium oxide. So we can convert the mole into mass by multiplying their molar mass. So molar mass of aluminium oxide is, so aluminium are 2, so 2 going to multiply with molar mass 27 in the periodic table, while plus the oxygen are 3 atom, we're going to multiply with 16 from periodic table value, and this will give us 102. This 102 will multiply with 0.17 mole, and that will give us a value 17.3 gram of aluminium oxide produced in the result of aluminium burn in the presence of oxygen and produce aluminium oxide. We are using following method. For example, if the aluminium react with oxygen and produce aluminium oxide, now on the basis of balanced chemical equation, first we have a molar ratio of 4:2, and second, we have a given mass. So we need to convert this given mass into the mole by following the formula. So mass over molar mass. So if we have the reactant mole, so we can convert the unknown product mole by using the molar ratio. And these unknown product mole are converted into the given volume or into the given mass by using this formula. For example, the moles multiply molar mass, we will get the mass of the product. That is 17.3 gram. We're going to see another example. So calculation of unknown quantity of the product. For example, if the 8 gram of sulfur is burned, what volume of sulfur dioxide is produced? So here in the reactant, the sulfur is given in the form of the mass, while the examiner asking the product in the form of volume. We're going to follow the same method. For example, first we're going to convert this balanced chemical equation. So first we'll write the balanced chemical equation and convert the mass of the reactant into the mole. And these, with the help of this molar ratio in the balanced chemical equation, we're going to find the unknown mole of the product. And these unknown mole of the product are converted into the volume. For example, Now, we have a chemical reaction. The sulfur is burned in the presence of oxygen, and that produces sulfur dioxide. Now, this is the balanced chemical equation. For example, the 1 mole of sulfur react with the 1 mole of oxygen, and that is producing the 1 mole of sulfur dioxide. So here we have a molar ratio where the sulfur and sulfur dioxide is 1:1. So at the standard temperature and pressure or the room temperature and pressure, so all gases, 1 mole of all gases have 24 dm³ of volume. So we're going to convert first the sulfur into mass into the mole. So molar mass of the 1 sulfur in the periodic table is 32. So we're going to divide 8 gram divided by the 32 mole per mole. So this will give us a value 0.25 moles. Now, the reference is the sulfur with the reference of sulfur dioxide. So in the balanced chemical equation, the 1 sulfur is 1 mole is producing 1 mole of sulfur dioxide. So 0.25 mole will produce X mole of sulfur dioxide. By the cross multiplication method, we're going to find the product of sulfur dioxide is the same 0.25. Why? Because the reactant and the product, the ratio is 1:1 mole. So whenever you find like the reactant and the product and the molar ratio is a 1:1 mole, so the number of mole of the reactant will be same amount will produce in number of mole of product. For example, the sulfur is 0.25 mole and the sulfur dioxide is 0.25 mole. Now we're going to convert these mole into the volume. So at the room temperature and pressure, so one mole of all gases have 24 dm³. So we're going to multiply this 24 dm³ with the given mole of the sulfur dioxide, and that produce 6 dm³ of sulfur dioxide. How did we find this method? So first, in a balanced chemical equation, we have molar ratio 1:1. So in the question, the sulfur mass is given. So by the use of the formula, we're going to convert this mass into the mole. So how? For example, the mass of the reactant is 8 gram. So we're going to convert it into the mole of the reactant, 0.25 mole. So for example, if this is 0.25 mole, so with the help of this molar ratio of a 1:1, so whenever there's a reactant ratio and the product ratio is the same, so the number of mole of reactant and the product will be same. Now, if we know that the product mole, we're going to convert it into the volume or the mass upon requirement. For example, if I need to convert it into the volume, so I will multiply with 24 dm³, so of the mole of the product, and this will give us the volume of the product. We're going to see another example, and in this example, if the 20 dm³ of hydrogen react with a sufficient chlorine, so that will produce hydrochloric acid. So what volume of a hydrochloric acid produced? Now in this example, the examiner is giving reactant in the form of the volume, while the product is required in the form of the volume. So here, this method will become more simple because we can directly find the reactant to the product. We are not supposed to change any value. For example, first we need the balanced chemical equation. Then we find the unknown volume by using the molar ratio or by using the volume ratio in balanced chemical equation. For example, if you have hydrogen react with a chlorine and that produce hydrochloric acid. Now, this is our balanced chemical equation. Now, in this balanced chemical equation, 1 mole of the reactant, hydrogen, is producing 2 mole of hydrochloric acid by reaction with the chlorine. So the molar ratio here, we are having what? The 1:2. So 1 mole of hydrogen is producing 2 mole of hydrochloric acid. So if there is a hydrogen is 20 dm³, so how many volume or how many mole, how many volume of, or how much volume of a hydrochloric acid it will produce? So with the reference of the reactant, we can find the product value. For example, let's suppose we have a hydrogen with the reference of hydrochloric acid. So at the room temperature and pressure, the 1 mole of hydrogen is 24 dm cube, while the 2 mole of hydrochloric acid is double of this, that is 48 dm cube. Let's suppose there's a 20 dm cube of hydrogen. How much volume of the hydrochloric acid will produce? So we're going to have the same cross multiplication method. By use of this cross multiplication method, so x is going to multiply with 24, 48 going to multiply with the 20 dm cube. Now this 24 in the next step, that is multiplying with the x, so it will divide on another side. So we will get the hydrochloric acid volume is 40 dm cube. So if the volume of the reactant are given, so we can easily find the volume of the product. Now we're going to see some questions relevant to this. So the equations show the reaction between the magnesium and the sulfur dioxide. So this question is worth for 1 mark, so that's why all required value will be given there. So the magnesium react with the sulfuric acid, and that produce the magnesium sulfate plus the hydrogen. In this reaction, which makes of the magnesium sulfate is formed when the 6 gram of magnesium react with excess of sulfuric acid. When we talk about the sulfuric acid, so it means this is an axis, so we need to ignore it. So we are going to measure the value of the magnesium, magnesium sulfate with a reference of magnesium. So here, these are 2 values. For example, let's suppose like the magnesium. So first we can convert this mass given in the magnesium is 6 gram. We're going to convert it into the mole. So 6 divided by 24 gram. So we will get 0.25, the 0.25 mole. Now these 0.25 mole, so we're going to see that the molar ratio of the magnesium and magnesium sulfate. And as we studied, if there's a molar ratio in the reactant to the product is 1 mole, so the mole of the reactant will be similar to the mole of the product. For example, 0.25 mole, that will be in a cross multiplication, we can find they're having 0.25 mole of the product. Now we're going to convert this mole into the mass. So directly 0.25 mole multiplying to molar mass 120 of magnesium sulfate, that will give us a 30 gram, and this will be our answer. Now this question you can also make it ready directly because you have a short time. So in this way, for example, the molar ratio in the reactant to product is 1 mole, so the magnesium will be 0.25 mole. And then directly you can multiply to the molar mass, and this will give us the value in mass. So we're going to see that another example. So the methane that react with the steam or water and produce carbon monoxide and the hydrogen gas. Now in this reactions, let's suppose the 0.5 mole per dm cube of methane react completely with 0.5 mole of the steam. So how much volume of a carbon monoxide and the hydrogen will produce? Now we need to find with the reference of the reactant and product, and you can see the reference of reactant and product is 1:1, while for example the methane is a 1 mole while the carbon monoxide is 1 mole. So in this way, with the molar ratio of a methane and a carbon monoxide is 1 mole. So how many mole of the methane? For example, this is 0.5 mole. So the carbon monoxide X, that will be have a same value. For example, you can see this is 0.5 mole. So that's why whenever you are finding the reactant to product molar ratio, so we can directly assume that will be a same mole. Now you can directly proceed to the conversion into the volume. So for example, 0.5 mole multiply into 24 dm cube. This will give us 12 dm cube of volume of carbon monoxide. Now, if you have the carbon monoxide, the 12 dm cube, so what is the reference of a carbon monoxide is a 1 mole, while the hydrogen is 3 mole. So the ratio of the carbon monoxide to the hydrogen is 3 mole. So in this way, for example, if the carbon monoxide is 12, so the hydrogen will be multiplied 3, this will become 36 dm cube. So your answer is D. You can also find another way. For example, we can also find the answer of the hydrogen or volume of a hydrogen with the reference of methane. For example, let's suppose methane, and that's going to be carbon monoxide. So we got this value. So here I'm going to replacing, for example, methane with a hydrogen. If I wrote the carbon monoxide, so you can replace it to the hydrogen. So 1:3, 0.5 mole multiply into the x, and that will multiply, this value will give us 1.5. If you're going to multiply this 1.5, and this value will give us 36. But it's better because this is MCQ, so there's very short time is given. So you should follow a direct method. For example, if you find one value of a carbon monoxide, directly converted the value of the hydrogen. Why? Because the ratio of the carbon monoxide and hydrogen is 1:3. So 3 multiply the volume of a carbon monoxide. This will give us 36 dm cubed. So we found this value, and we're going to move to another example. 0.5 gram sample of a calcium carbonate react with excess of dilute hydrochloric acid. So here, the calcium carbonate react with a hydrochloric acid, and that's going to produce of the calcium chloride plus water and plus carbon dioxide. So which volume of a carbon dioxide is produced at the room temperature and pressure? So here, there's a molar ratio is a 1:1. So whatever the volume or whatever the mole of the reactant, same mole of the product will be. So first, we're going to find the mole of the reactant. For example, the calcium carbonate. So mole, the mass of the calcium carbonate is 0.5 gram divided by its molar mass. So this will give us 0.005 moles. Now these 0.005 moles, so this will give us the value. So with the reference of calcium carbonate, we are supposed to measure the value of the carbon dioxide. So how we can measure? So directly, for example, with the ratio of a calcium carbonate with a carbon dioxide, this will give us a 1:1 molar ratio. So the same amount, for example, if we say like ratio is 1:1 mole, so the calcium carbonate, how many mole of the calcium carbonate, same mole of the carbon dioxide it will be. So we're going to convert it into the mole. So 24 dm cubed multiplies 0.005 mole of calcium carbonate, and this will convert into a 0.12 dm cubed of a carbon dioxide. And that will be our answer, A. So here we studied about if we have the balanced chemical equation, so how we can find the unknown quantity of the reactant and product. Hope you got an idea and it will be helpful for you. If you have further questions, you can put it in the comment box. So I will further upload the videos related to that. Thank you. Thank you very much.